In today's lesson, we are going to be looking at the sine wave. Now, this is one of the main periodic functions that we will start to look at as we continue through this course. So we're just going to look at the basic characteristics of a sine wave. Now, we are going to do an investigation in class looking at spaghetti trig. So it's more of just like an interesting way just to kind of graph or to visualize what a sine wave looks like. So we'll go through the instructions. If you want to try this at home, you're more than welcome to. But again, we will be doing this in class. So you're going to need some spaghetti, dry spaghetti, 2 pieces of legal-sized paper taped together, or some tabloid paper, it might be the other term for it, just large paper, tape, yarn, and a unit circle. So a unit circle is basically a circle that's showing all of the degrees. So what you're going to do is you're basically going to tape the pieces of paper together. You're going to fold them in half the long way and draw a line down the middle. You're then going to draw a perpendicular line so that in the end you're going to have basically an x and a y axis, because we are going to be graphing essentially this sine wave. Next, you're going to use the unit circle. You're going to wrap yarn around it so that the length is the circumference of the circle. Change that to so. So the length is the circumference of the circle. So you essentially would have a unit circle, right, starting at 0, we got 90, 180, 270, and back to 360. So you are going to take a piece of string and basically just wrap it around the circle and cut it. So you want one piece of string that is the length of the unit circle. You're going to use the marker, or use a marker, and mark each indicated angle that is on the unit circle on the yarn or string. So we will look at that. But you're basically going to go through and mark each one. You're then going to place the yarn down onto your x-axis. So again, if we had our horizontal, this is back on the paper, when we folded it and drew the perpendicular line, you're going to lay the yarn down on the x-axis, and then you are going to make the marks, or just put down the tick marks on your x-axis, maybe 30 degrees, 45, 60, 90, and so on. So you're going to be putting those marks down on the x-axis. You are then going to take a piece of dry spaghetti and break it so that the vertical distance is from the initial angle 0, which is down here, right, 0 is along that line, up to 30. So we're going to have a piece of dry spaghetti that is the length from this 0 up to 30. You're then going to take that piece of spaghetti and tape it on the mark that says 30. You're going to tape that piece of spaghetti. So something like that. You're then going to continue to do that for all of the points on the circle, so all of the degrees that are given. So we just did 30. You're also going to do 45, then a piece for 60, then a piece for 90, 120, 135, 150, and so on. Obviously at 180 you would have 0. You would take all of those and you would place all of those values, or all of those pieces of spaghetti, onto your x-axis at the indicated spots, which you had done previously. So you would have something, we had 30, 45, 60, 90, things like that. So you would have pieces of spaghetti, something like that, and it would continue for all the other ones. Above each piece, you are going to write the y value of each sine, or of sine at each angle measure. So essentially for the first one, you're going to do sine of 30. You would get 0.5. Do sine of 45, or whatever the next mark is. So you did sine of 45, you might get 0.71. Sine of 60. 0.87. Sine of 90. Get 1. And you're going to repeat that for all of the different tick marks that you have. So you're just basically going to put the value above each one. So we know how tall our piece of spaghetti is based on the scale. Right? So then you're going to go through and complete the table. So for all of these, you're going to do sine of the angle. So we'll just do the first couple ones. Sine of 0 is 0. Sine of 30 is 0.5. Sine of 45 said was 0.71. Sine of 60 0.87. Sine of 90 was 1. And you can continue on for the rest of them. So you're going to fill in that table. You're then going to answer a couple questions. Is the curve a function? So yes or no, is the curve a function, and explain how you know. Is the domain, or what is the domain for this function? Well, we kind of just answered the question there. Yes, it will be a function. The domain and range, I will let you figure that out for yourselves. You could also look at the angle values that we have here, because these would be our x, and our sine values would be our y. And again, because it is a function, we have a straight line essentially on our graph. Our domain is going to fit that template that we talked about. So x is any real number, given that it is between two values. Same with the range. Y will be any real number, given that it is between a range. Right, so when you fill out your sine wave, you're going to complete this domain and range. What do you think will happen after 360 degrees? So what do you think would happen? Because again, we are only going to look at 360 degrees. So think about what you think would happen after 390, 420, right? 450. What would happen after that? Because we can have degrees higher than 360. But we're only looking at 0 to 360. So what do you think would happen after? What do you think would happen before? So negative 30 degrees, negative 45, negative 60, and so on. Right? If you want, you can plug those values into your calculator and see what you would get. See if there's some sort of kind of relationship there. Right? So think about what would happen after and before the function or the graph that we have. So what you've created with the spaghetti, you've created your own sine wave. So we're just going to look and summarize what you should have found or what we should know about our sine wave, because this is one we're going to use further on. So as a review, some terminology, right? Talking about the equation of the axis. This is the horizontal line that is halfway between the maximum and the minimum, or halfway between our function. We have a formula for it. The maximum plus the minimum divided by 2. The amplitude, or I guess we can draw it in over here. So this is our axis there. The amplitude is the distance from the axis to either the minimum or the maximum. The distance from the axis to either the maximum or the minimum. It is always positive. We do have a formula, the maximum minus the minimum divided by 2. If you look at our diagram here, I have my axis here, and then I have our amplitude going from the axis to the maximum or from the axis to the minimum. The period is the length of one cycle, so one repetition. One full repetition, however long that takes, that is our period. So our sine wave should look something like this, right? We've only looked at between this value and this value on our sine wave, but we should see that it does continuously repeat as we go beyond 360 or if we go before. So that kind of answers one of those questions that we just had. So the sine wave, we do have a couple of key points that I've already labeled here for you. We should have seen these on the sine wave that we made as well, right? Because those are the ones that turned out to have nice numbers. And again, these are some of the important points. So the characteristics of our sine wave. the period. What is the length of one repetition? Well, if I kind of highlight one repetition, what is the length? How long does it take for one repetition? Or how many degrees? Well, it is 1 unit circle, or 360 degrees. Let me change this a bit. In general, what is the maximum value? What is the highest value? Well, the highest value, in this case, we're talking about the y value, is 1. The highest value is 1. The lowest value don't actually have it labeled here, but it is right in between 210 and 330, so it is 270. So lowest value here is -1. The equation of the axis, we could visually see it, right? The equation of the axis, we could visually see that line that cuts our periodic function in half. Oops. We could also use the formula, right? Max plus the min, so 1 plus -1 divided by 2. So this is 0. So our equation of the axis is 0. Our amplitude, what is the height or the distance from the amplitude or from the axis to either our maximum or to our minimum? Well, we could use our formula. We could look specifically at this. So 1 minus -1, so the max minus the min, divided by 2, and we get 2 divided by 2, which is 1. So the amplitude is 1. The domain, the x values, because it does continue on forever, we can say that x is equal to any real number. Now, if we're talking specifically about the one cycle, it is 0 to 360, but in this case, we can just say x is a real number because it does go on forever. The range, looking at the y values, the range would be, in this case, y is any real number. However, there is a condition. It has to be between -1 and 1. Right? The y value doesn't get larger, or doesn't go above 1 and doesn't go below 1 for our standard sine wave. We will look at other examples later on where it is, or that does change, but for right now, the basic standard form, the range is between -1 and 1. Our 5 key points, or some key points to look at, right? So these are some key things that we want to make sure that we're aware of, and essentially those are the nice values. So we do have a few more labeled here, but looking at some of the key ones, basically when it touches 0 and when it reaches its maximum and minimum, those are the key values. So we'll have 0 and 0 as one value, 90 and 1 as another, 180 and 0, 270 and -1, and 360 and 0. So essentially every 90 degrees that we move along in our sine wave, that gives us a key point. Either it's going to be at 0 or it's going to be the max or the min. So those are the nice key points, because really if I have those key points, I can graph, or I can at least sketch my sine wave. I could say the half values, but again, if I'm just looking at the main ones, the max, the min, and where we touch 0, or those midpoints. So those are the kind of 5 key ones. So the main thing from this lesson is just looking specifically at the sine wave. We made one, or in class we made one out of spaghetti. And again, the key characteristics, using the terminology that we've already talked about for periodic functions, applying it to this specific sine wave, because as we get further in this course, we will use the sine wave a bit more, and it does help to know some of these characteristics of it.